In this video, we're going to look at how we differentiate a quotient. Now, a quotient is in the form of y is equal to u over v, where u is a function of x and v is a function of x. Your rule for this is if you differentiate y, if it's y is equal to u over v, dy by dx is equal to v du by dx minus u dv by dx, all over v squared. Okay, so the order of these now does matter because this is a minus sign, so it's v du by dx minus u dv by dx all over v squared. Okay, we're just going to look at a few examples of this using our quotient rule. So in the first one we have y is equal to x squared minus 1 over x squared plus 1. So in this one we're just going to set it out and say your u is equal to x squared minus 1. That means your du by dx is equal to 2x. Your v is equal to x squared plus 1. That means your dv by dx is also equal to 2x. So your dy by dx is equal to v first of all, and v was equal to x squared plus 1. So just use brackets, maybe use more brackets than necessary even, it doesn't matter. So that's my v, and then du, which was 2x, minus my u, which was x squared minus 1, times my, that's my u dv by dx, and all divided by my v squared. So v squared is x squared plus 1 all squared. Now experience will tell you just leave it as that. Sometimes there'll be something that will cancel out once you tidy it up, so leave the squared bit in it and hopefully something cancels out. Okay, if we go on with this one, if we multiply this bracket, let's just think, we're not going to actually write it out, just think what's going to happen. You're going to have x squared times 2x, but over here you're going to have minus x squared times 2x, so they will cancel each other out. You're then going to have x squared times 2x, you're going to have 1 times 2x, and then you're going to have minus 1 times 2x. So what you're really going to have is 2x plus 2x, so the top line is just going to be 4x, and then bottom line is x squared plus 1 all squared. Now in this case there was nothing that cancelled out, unfortunately. That's as good as we could go. Okay, for example 2, I will just change to blue, and I will, so this is my example 2 now, and I'm going to write down my u first of all. U is equal to 4x minus 3, and that was to the power of 6. So my du by dx is going to be equal to 6 upon 4x minus 3, that's to the power of 5. That was me differentiating with respect to the bracket. Now differentiate inside the bracket, you get 4. So that works out to be 24 upon 4x minus 3 to the power of 5. My v is much easier. It is equal to x plus 2. And my dv by dx is equal to just 1. Okay, so this is my example 2 I'm doing here, sorry. And then if we just continue on with this, I'm just going to write down the formula again. Dy by dx is equal to v du by dx minus u dv by dx, v du by dx minus u dv by dx all over v squared. Okay, not easy this one. There's a good bit of tricky cancelling down to do. So first of all, write down your v, which was x plus 2. And it's multiplying my du, which was 24 upon 4x minus 3, and it's to the power of 5. And then minus my u, which was 4x minus 3 to the power of 6, and it was multiplying dv by dx, which was just 1. So we'll just leave it as it is. We don't need to put in the 1 if it's multiplying. And then v squared is just going to be x plus 2 all squared. Okay, good bit of tidying up to do here. Our x plus 2 squared stays on the bottom line. Top line, what we can pull outside a bracket is 4x minus 3 to the power of 5. So we'll do a square bracket. What you're left with inside the bracket then is 24 times x plus 2 minus 4x minus 3. That's just the power of 1. And your last line, tidy up, you're going to have x plus 2 squared on the bottom line. Top line, you're going to have 4x minus 3. And then inside this bracket, let's think about what this is going to be. You have 24 times x, then minus 4x is just going to give you 20x. And then you have 24 times 2, which is going to be what? 24 times 2 is going to be 48. Then minus 3, which means plus 3. So 48 plus 3 would be 51. So plus 51, and that's that example. That's a bit squeezed in there, apologies for that, but hopefully in the notes when you have them printed off you can see them. Okay, example 3, you've got your u again is equal to 3x squared. That means your du by dx is equal to 6x. Your v is equal to e to the x. That's a nice easy one. Your dv by dx then is equal to e to the x. So here we'll say that means, we'll go up here just and say your dy by dx is equal to v first of all, times du, which is just 6x, minus u, which is 3x squared, times my dv, which again was e to the x, all divided by my v squared, so that's going to be e to the x. I'm just going to write it as e to the x all squared. You could write that as e to the 2x, but you'll see it just makes it easier when I'm going to cancel, as I will in probably the next couple of lines. Top line, factorize out whatever you can. I can pull out a 3x and an e to the x, square bracket then, leaving me inside with 2 minus x just, that's all. And the bottom line was e to the x, and that was squared. Now because I've left it that way, it's easy for me to see that this e to the x here would cancel with one of these e to the x's, so just leaving you e to the x on the bottom line, and top line is 3x upon 2 minus x. Okay, example 4, your u is equal to ln of x. That means your du by dx is equal to, differentiate ln of x, remember you get 1 over x. Your v is equal to e to the x, so your dv by dx is also equal to e to the x. So your dy by dx, remember this is your v du, I'll just write it down this time, v du by dx minus u dv by dx, all divided by v squared. So v first of all is e to the x, your du by dx was 1 over x, minus your u, which was ln of x, I'll put that in a bracket, and my dv by dx was also e to the x, all divided by my v squared, which is e to the x all squared. So very similar to your last example really. Factorize out, top line you can factorize out an e to the x, so it's going to be 1 over x minus ln of x, and your bottom line you just had your e to the x all squared, and you can see this e to the x cancels out with one of these ones, leaving you e to the x on the bottom line, and your top line is 1 over x minus ln of x, and that's it. Okay, you could write this one more line just to write it in, write it slightly differently, put it all in one line, e to the minus x upon 1 over x minus ln of x, but this way is just as good, to be honest. Okay, we mentioned these in the previous video where we're looking at differentiating trig, but we're just going to look now how we can prove these things. So you've got tan of x. If you differentiate tan of x, you get sec squared. Differentiate cosec, you get minus cosec cot. Differentiate sec, you get sec tan. Differentiate cot, you get minus cosec squared. And it says, very important here, only prove them in an exam if asked to do so. You're able to just use the results otherwise. Okay, we're going to look at the proofs of these now, and then look at how we can apply them in questions. Okay, the first one we're going to prove is the derivative of tan x. Now we're going to look at, I've started this off for us here, and I've said tan if y is equal to tan x, therefore you can write this as y is equal to tan x, then y is equal to sine x over cos x. So your u is equal to sine and your v is equal to cos. And we've differentiated our u to give you cos, differentiated your v to give you minus sine. And then where we're going to pick up, we've written down the formula for the quotient rule, and we're just going to fill this in and see where we go to. Okay, so your v was cos x, your du was also cos x, then minus, and your u was sine x, and your dv was minus sine x, and your v squared is v was equal to cos, so v squared is going to be cos squared x. Now let's have a look at our top line. The numerator is going to become cos squared x, plus sine squared x, all divided by cos squared x. Now if you look at what this is, cos squared plus sine squared is 1. So 1 over cos squared x, and which cos is the same, 1 over cos is the same as sec, so 1 over cos squared is the same as sec squared x. So what we have shown is if your y is equal to tan x, then dy by dx is equal to sec squared x. Okay, the second one, we're not actually going to use the quotient rule. It says this is us proving the derivative of cosec. So cosec is 1 over sine, and you could write that as brackets sine x all to the minus 1. So then we're going to differentiate this thing, so differentiating sine x to the power of minus 1. So it's a function of a function. So differentiate with respect to the bracket, you get minus 1 upon sine x, that's now to the power of minus 2. And differentiate with respect to the bracket, i.e. differentiating inside the bracket, differentiating the sine, you'll get cos. So tidy that up a wee bit, that's going to be minus cos x divided by sine squared x. And we're going to just split that up and say that's the same. That's going to be the same as minus cos x over sine x times 1 over sine x, which is the same as the 1 over sine x, this bit, 1 over sine x is the same as cosec. So we'll just have minus cosec x, and cos over sine is the same as cot x. So there's another one of our results. Okay, our third one is very similar. I've just done the whole thing out. If you let y equal sec x is the same as 1 over cos x, which is the same as brackets cos x to the power of all to the power of minus 1. And if you differentiate this, differentiate with respect to the bracket, you'll have minus 1 times cos x to the power of minus 2. And differentiate inside the bracket, you'll get minus sine x. So multiply these two things together, you have sine x over cos squared, which is the same as sine over cos upon 1 over cos. And the 1 over cos is sec x, and sine over cos is tan x. Okay, and the last one, which is very similar to differentiating tan. If you write your cot as cos over sine, then your u is equal to cos x, so du by dx is minus sine. V is equal to sine, so dv by dx is cos. And then this is your v du minus u dv all over v squared. So your top line, sine squared times sine times minus cos times cos becomes minus sine squared minus cos squared, or you can take a minus outside the bracket, leaving you sine squared plus cos squared. Sine squared plus cos squared we know is 1, so minus of 1 is minus 1. So we have minus 1 over sine squared, which is minus cosec squared. Okay, now in these examples we're going to use the results which we have just proved. So the first one says, differentiate the following with respect to x. Y is equal to sec of 2x plus 3. So if you differentiate sec, we know from what we have just done, if you differentiate sec, you get sec x tan x. So here we're going to get differentiate sec of 2x plus 3. You're going to get sec of 2x plus 3 upon tan of 2x plus 3. So notice the angle part, this stays the same. Then if you differentiate the angle part, you will just get 2, and that's it. Okay, the next one, you've got cot of 5x, and we know from what we have just done, if you differentiate cot, you get minus cosec squared. So here it's going to be minus cosec squared of 5x, and if you differentiate the 5x, you get the 5, so minus 5 cosec squared 5x. Okay, the next one is just differentiating cosec of 3x squared plus 5x. So if you differentiate cosec, you get minus cosec cot. So here, differentiate this, we'll get minus of cosec, and the angle is 3x squared plus 5x. And then cot, again, 3x squared plus 5x. And if you differentiate 3x squared plus 5x, you will get 6x plus 5, and that goes in a bracket in front. So that is it, done. Okay, folks, you're now ready to do topic 6. Topic 6, exercise 6, questions 2 to 4, and then exercise 7 could be done as well. It's but there's no answers, but it's just a homework exercise.